Hello, I'd like to go over what we've been talking about in class yesterday and today. We are still tackling this concept of fractions as division. Students were given a short little worksheet here that I made up, 4 questions. Yesterday, with the exception of Mrs. Broadwell's class, they will be receiving this paper tomorrow. Students will be graded on this, but students can always correct everything in class. So if they make some mistakes and don't get as high of a grade as they'd like, it's not the end of the world. They can simply choose to make corrections and turn those corrections back in with this paper, and I will evaluate those corrections and update the grade as needed. Anyway, I want to go over these 4 problems to give you an idea of what we've been working on. So for these first 2 questions, students need to use a diagram to answer. So a diagram is essentially just a quick little sketch or picture to help them conceptualize what's really happening in this situation. So number 1, Mr. Smith bakes a cake. He shares it equally with 4 friends. What fraction of the whole cake does each friend receive? So we're dividing a cake here. There's 1 cake, so I am going to draw just 1 hole here. And then I share it equally with 4 friends. So it's important to realize here that because I am sharing it, I'm eating the cake too. So between the 4 friends and myself, there are 5 people eating this cake. So the division expression that matches this situation is 1 whole divided by 5. So I'm going to divide my 1 whole cake here into 5 equal pieces, and I know that I'm going to get one of those equally sized pieces for my piece of the cake, and the size of this piece is 1/5. So each person is going to receive 1/5 of a cake, or 1/5 of the cake. The next question or scenario says Emilio buys 2 foot-long subs. He shares them equally with Aiden and Alyssa. What fraction of a whole sandwich does each person receive? So again, we're dividing 2 foot-long sandwiches. We want to make sure that we are dividing the dividable noun in the problem. So the 2 main things in this problem that are named and counted are the foot-long subs and then the people. We want to make sure we're dividing the subs. We're not dividing the people. So there are 2 subs. Here's one of the subs represented as a rectangle. Here's another sub represented as a rectangle. And again, we need to be aware that in this problem, Emilio is sharing with Aiden and Alyssa. So that means there are 3 people who are going to be enjoying these 2 subs. So the division expression that models the situation here is 2 divided by 3. So I've drawn 2 holes to represent my 2 foot-long subs, and I'm going to divide each of these subs into 3 equal pieces. Now, if I'm Emilio, I'm going to be eating 1 piece, 1 of the equal pieces from the first sandwich, and another equal piece from the second sandwich. These are 1/3 pieces. So altogether, that would be a total of 2/3. So each would receive 2/3 of a sandwich. All right, so let's drop down. There are 2 more questions. The directions state for each expression, write a matching scenario and answer it. I noticed that this word here was confusing some students. So by scenario, I mean a story problem, a word problem, some type of situation that matches these 2 expressions. So for question 3 here, we're dividing 2 wholes into 5 equal groups. So we want to make sure that whatever the 2 wholes are, it's something that can be divided or put into groups. Food is usually something that works well with fractions, particularly when we are dividing whole numbers or fractions. So let's say that I have, let's say there are 2 pizzas, and we'll say they're shared equally. And it's important to qualify this by saying we are sharing equally, because division is all about sharing equally, equal groups. This equally is very important. So there are 2 pizzas, or 2 represents pizzas, shared equally by 5 people. So this would be our situation. Now, if we asked what fraction of the pizzas does each person get, we can answer that question by knowing that 2 divided by 5 is equivalent to the fraction 2/5. So a fraction, again, is essentially a division problem here. We're saying we have 2 parts, and we're sharing them equally into 5 groups. And for students who are not yet convinced that 2 divided by 5 is equal to 2/5, drawing a diagram where we have 2 whole rectangles and then dividing those rectangles into 5 equal pieces and using the scenario to help understand what's happening in the diagram should help clarify why 2/5 is equal to 2 divided by 5. Okay, so we have to do the same things for the 4th question here, or 4th problem. We have 3 divided by 4. So we have 3 whole somethings being put into 4 equal groups, or being shared equally amongst 4 people, or 4 dogs, or 4 cats, or whatever the situation may be. So I'll say there are 3 bags of popcorn shared equally by 4 students. And if we asked a similar question to question 3 here, we could say, what fraction of the popcorn would each friend receive? And again, students should recognize that 3 divided by 4 is expressed as a fraction 3/4. But again, if the answer to 3 and 4 is not clear, going back to using diagrams and pictures along with using the scenario should help make sense out of which fractions would be equivalent to these expressions. Now, today we started talking about the connection between multiplication and division. We talked about what students already know about the relationship between multiplication and division, and many students pointed out that when solving a multiplication problem, they can check the accuracy of their product using division. And when they find a quotient when they're dividing, they can use multiplication to determine whether that quotient is accurate. So in talking with the students about that relationship where we can kind of think of multiplication and division as opposites, we started talking about what multiplication and division look like when we're dealing with fractions and how we can use multiplication and division to make sense out of the same situation. So before we really dug deep into that, the first thing that I showed students was this expression here. So I told them that if 4 times 3 is equivalent to 4 groups of 3 added together, that if this expression is true, then what would 4 times 1/3 be? So in other words, what would the product of 4 and 1/3 be? So students are very familiar with using repeated addition as a multiplication strategy. In fact, at the beginning of the year, when we were in our multiplication unit, many students still relied on repeated addition as their go-to strategy. So after examining this expression here, students made the connection that 4 multiplied by 1/3 is equivalent to 4 groups of 1/3 added together. And so because there are 4 1/3s here, they knew that 4 multiplied by 1/3 would be equivalent to the product 4/3. And some students even recognize that 4/3 could be expressed as 1 1/3 as well. And we had some conversations about that. But the main point for me was to help students understand that the meaning of multiplication hasn't changed just because we're introducing fraction factors. We're still talking about a number of groups that have an equal value. So this would be 4 groups of 1/3. So understanding that multiplication as an operation is in fact repeated addition. As we work through some examples, students recognize that a more efficient way of evaluating 4 by 1/3 would be to simply multiply the whole number in the numerator while keeping the denominator the same. And so that was a really neat connection for students to make as well. But what was really interesting was many students decided to use what they know about dividing and the diagrams we've been using to actually create a diagram that shows 4 groups of 1/3. So I had several students throughout the day draw a diagram like this. So 4 boxes to represent 4 holes. They divided each of the boxes or rectangles into thirds. They colored or circled or labeled each of the thirds in the 4 holes, and they knew that this was visually representing 1/3 plus 1/3 plus 1/3 plus 1/3, and also got the product 4/3 when they multiplied 4 by 1/3. But what was really, really interesting about this is it led perfectly into our conversation about how multiplication and division can represent the same situation. So what I did was I drew a diagram on the board, and I had students watch me carefully so they didn't miss anything. And so just as you're watching what I did here, I asked the students, mathematically, what did I do? Can you tell me what I did using a math expression? And so students recognize, okay, you drew 2 holes, and then you divided each hole into 3 equal parts. So this situation can be described using division as 2 divided by 3. And I challenged them to find a different way to look at this problem in order to come up with a multiplication expression that would also result in 2/3. And so what do I mean by that? Well, if we divide the 2 holes into thirds, we see that what we've done is we've represented 2/3. There's a third from this hole, a third from this hole. So there's 3 groups of well, I'm sorry. There's 3 groups of 2/3 here. So I challenged the students to figure out, okay, what would be a multiplication expression that would also show 2/3. And a lot of students at first thought, well, I think maybe he's asking for 2 times 3. And we started talking about it, and 2 times 3 is 6. And I asked the students, well, what is that 6? What size is that 6? Is that 6/3? Is that, what is that? So we found out that this is 6 holes. And so when I drew 6 holes using these rectangles, it became apparent that 6 holes is a lot bigger than 2 holes. So 2 times 3 does not match this situation, and it certainly doesn't result in 2/3. Well, when I reminded the students, hey, think about this as repeated addition. 4 times 1/3. Remember, it was 4 groups of 1/3, and we added those together to get 4/3. Then it became a little more clear now that, wait a second, I have 2 groups, and the value is 1/3 here. I have 2 groups of 1/3, so I can write 2 multiplied by 1/3, and that also gives me 2/3. So looking at this situation here, it could be interpreted as 2 divided by 3, or it could be interpreted as 2 multiplied by 1/3. So I challenged kids after we went through that. I challenged them to think about this situation. So I said 5 kids share 3 burgers equally. Now, can you represent the situation with multiplication? And can you represent the situation, oops, oh my, sorry about that. And can you represent the situation with division. So a lot of students thought, well, I'm going to draw the situation here. And I think that's a good idea because it really grounds our thinking and what's really happening in this situation. And it just kind of slows everybody's minds down a bit to really process what the question's asking. So we have 5 kids. They share 3 burgers equally. Now, between these two nouns, we are definitely going to be dividing the burgers. So to represent this situation, I am going to draw 3 burgers. And since they're squared-ish, you can think of these as 3 singles from Wendy's. And because we're dividing each whole by 5, so that each kid gets an equal amount of burger, what I've done is I've divided 3 burgers by 5 kids. So right off the bat, when I draw this diagram, I see, the division expression here is 3 divided by 5. And then when I think about how much of a share each kid would get from each burger, I see, well, they'd get a 1/5 from the first burger, they'd get a 1/5 size piece from the second burger, and they'd get a 1/5 from the third burger. So altogether, that'd be 3/5, but look, this looks a whole lot like repeated addition. So what I also have here is 3 groups of 1/5, so my multiplication expression is 3 groups of 1/5, or 3 multiplied by 1/5, and that also gives us 3/5. So we have agreements here, or congruence, or agreement. I guess I combined those 2 words. We have agreement between the multiplication, the division, and then also the diagram here. So that lets us know that we interpreted this situation correctly and we were able to represent it accurately. So those are the things that are going on in class this week. As always, if you have any questions, please don't hesitate to get in touch with me through email or through Remind. Thank you.